Hi, everybody, and welcome to today's webinar on private networks for mining. My name is Kelly. I work in marketing at IBWave, and I'm joined by my colleague, Milton Melba, who will be the presenter today, and a sales engineer at IBWave and a specialist in designing for mining environments. Before we get started with the webinar, I'm just going to go through a few housekeeping items with you. We are recording the webinar today, so everyone will receive a copy of that video, and that we encourage you to ask questions as we go. Please use the GoToWebinar questions box on your screen, and we will get to your questions as best we can at the end of the webinar. And so that's it. At this point, I am going to hand it over to Milton so we can dive right into the private networks for mining. Milton, over to you.
Okay, thank you, Kelly. Just a fast introduction myself. I have more than 20 years of experience in wireless network systems, working with design, optimization, project management, and I'm working IBWave since 2012. And I'm sales engineer, and I'm part of the Americas engineering team. I'm based in Brazil, and thank for everybody that is sharing your time today to talk a little bit more about private network for mining. We prepare an agenda today to talk a little bit about an overview about the private network market. When we prepare some overview about some specific market in IBWave for the webinars, we prefer to work with some neutral and third-party companies. So we have a partnership with Disruptive Analysis. Disruptive Analysis is a consulting company that provide some analysis and strategic consultant for different markets. And in this part, we like to provide what are the motivations and the tendencies of the private network. And after that, we will talk specifically about mining private networks for mining. So we will present some existing use cases in the market already, the different technologies and challenges to perform wireless designs in these type of environments. And then I will show you how IBWave solutions can help to solve those challenges and to do a complete design in different types of mines. And I will present a demo in different types of environments. And we have some time in the end of the webinar to questions and the answers. So let's start talking about the private networks around the world. Here is just an overview about the private network, especially the motivation and tendencies for this market. And when we talk about the future wireless systems, this is a very interesting slide, because here, some years ago, when we talk about the future of the wireless systems, we are talking about different dimensions, right? And some years ago, basically, we are talking about 5 specific dimensions. The importance of the wireless networks for the business, right? The range of the price, of course, and based on the range, we can solve with different technologies and in the protocols. Of course, the bandwidth that is increasing year by year for different applications. The coverage as well, depending of the area, if you are talking about a urban area or a rural area. And the 5th dimension here, some years ago, was the power of the system, or the power of the different solutions that we will use in the wireless system. But right now, we can change this 5th dimension to the spectrum usage. Why? Because in the last years, we have new spectrum usage options. So normally, we have the unlicensed and the licensed spectrum, and right now we have another options like the shared spectrum usage, right? And we have now another dimension, that is the business model. So we have new business model in the market, so we have new options to create our wireless networks. And of course, we are talking about much more aspects, some technical aspects, some geographical or geopolitical aspects. So we have here latency, of course, is a important thing right now. The mobility. So we have a lot of things more, and probably in the future, maybe we will replace some dimensions, or we will have more dimensions, right, for the future wireless systems. But specifically for 4G and 5G networks, we have been had new forms emerging in the market. So we started with the microcellular systems. Then we start to see the neutral host cellular systems, and in the last years we started to see exactly the private cellular systems. And what were the motivations to start with the private cellular systems? Disruptive analysis classified these motivations as the 4 C's of private cellular networks: coverage, control, cost, and compensation. Basically, the different markets and the different companies start to see new motivations to start with the private cellular. For coverage, for example, looking in different types of environments, we have in-building projects, industrial areas, offices, metro areas. The governments are looking for new private cellular networks. And of course, the different companies start to see different necessities to control the system, since the security up to customized systems, the deployment, the life cycle of each design. And of course, they are looking for cost, right? So looking for cost, they are looking to replace a legacy LMR, fiber replace, different types and new types of cellular systems. And of course, they are looking for some compensation, right? In productivity or roaming or different types of compensation. But basically with these 4 motivations, we start to see the beginning of the private networks. And right now we have around the world something around 300 to 400 existing private networks. And we have private networks in different verticals, in different types of markets: manufacturing, chemicals, warehouses, airports, public safety, mine, oil and gas, campus. All these different verticals has some companies that start to see these motivations, and they start to create their own cellular systems. And of course, the private cellular networks depends of the range of the project, right? So if we put the projects in vertical network scale regarding the range of the project, we will see more or less potential number of networks per country or per region, right? So in the small ones, we can see more potential, right? Like the office business, office buildings, shopping malls, hotels, stadiums, warehouses, logistics market, right? And of course, then we have largest ones like the hospital complex, university campus, the airports, ports. And here, of course, for the large ones, we have a less potential number of networks. But here we can see the topic of this webinar, right? Mining and oil and gas and environments. And another thing that we need to pay attention is that it's not so easy to create a private network, right? So when we need to create a private network, we are talking about a lot of moving parts, a lot of different aspects, parameters, and a lot of things that we need to have. So here we have some examples, since the spectrum usage up to the different types of solutions, small cells, Wi-Fi, cabling, the backhaul, transport network, core network, different types of different types of applications, devices, chipsets, the different types of services, right? Voice, PPT, video, message. So for each one, we will have different types of applications. And then for this reason, how we have this lot of moving parts, a fully private cellular network are not the only answer. We will have a lot of different business models to implement our own private network, right? So since the more simple one, the private Wi-Fi network and LPWAN network, up to an enterprise private mobile network, for example. But here we can see a lot of different business models, right? And we have much more. We have many hybrids and variations that we can implement here in our private cellular network. So the message is not so easy, but we have a lot of options to implement a new private network. And every time that we talk about private network, we have a typical question, right? If the alternative networks, for example, will replace the Wi-Fi, or how is the competitiveness scorecard between Wi-Fi and the new alternatives private networks? And here we can see that the answer is depends, right? Because we need to see that in different types of environments, in different types of markets, we will have some technologies that is optimal for each one or problematic for another ones. So if we start to look at the Wi-Fi, we have Wi-Fi as an optimal solution for some of these applications or these environments, but we have a problematic Wi-Fi solution for another ones. And even the Wi-Fi is changing, right? Right now we have Wi-Fi 6, and even the Wi-Fi 6 is right now is better or is more optimal for some ones, and is better or worse for another ones. But when we look for the alternative networks, we can say that the alternative networks has the same application. They will be better for some environments, worse for another ones. So in general, we can say that, in fact, I think that one will not replace another. Everybody will live together, right? And we will reach different environments and with different applications and solutions. And the 5G will drive transformation of telecom itself, because if you look for the 5G era of mobile operators, normally we have the traditional operators, right, in national and national operators. Depending on the country, you can have 1 up to 4 or 5 traditional mobile operators. But in the last years, we could see the tower codes, we could see the virtual mobile network operators, right? And with the 5G, the expectation is to have a consolidated national MNOs. We will still have the national MNOs, the traditional ones, but we probably will see a lot of new models of mobile networks operators, rural, vertical, military, city, hybrid, a lot of new forms driven by the 5G in the market. And when we talk about mining private networks, mining private networks is real right now in the market, right? We have a lot of companies, a lot of mining companies with their own private networks, and we will talk about the existing use case that we have in the market, the different technologies, and of course the challenges for wireless networks in the mining environments. Some important numbers that we have here for the private LTE market in mining environments, for example, the size of the global private LTE market is projected to grow from $4 billion in 2020 and 2021 to $7.1 billion in 2025, with a compound annual growth rate of 13.6%. So it's a huge number for investments just in private LTE market, right? For private LTE wireless networks, and specifically for mining, we have another interesting number that show that 61% of the top 50 mining companies around the world already have some private LTE or 5G communication system in their operations. And the investment in telecommunications today is one of the top 5 priorities of the mining companies, if you look the biggest ones. And why? Because we already have a lot of use cases in the market, existing use cases with different technologies. We have a very common use case right now, that is the autonomous truck operation. We have the smart conveyor belts as well as a very important use case for private networks, and the geolocation of machines, the geolocation of people in the mining operation area. So all these use cases works with different technologies, right? So we have a lot of new applications, especially to bring the industry 4.0 to the mining operations. So when we talk about technologies, we have a lot of technologies running in the mining operation right now, since the public safety technologies up to Wi-Fi, cellular technologies, 4G, 5G, and even for IoT networks, we have some specific technologies like LoRa, for example. And what is the challenge for wireless technologies in the mining environments? Typically, we can divide the mining into different types, right? The surface mining operation and the underground mining operation. But the challenge is very similar for both. The first one is the environment, right? A mining environment is an environment that is constantly changing, right? So and more than changing, we have an existing environment that normally is very aggressive for wireless technologies, right? Is a typical environment that is not so easy for the wireless propagation, especially regarding the materials, the tunnels for the underground mines, for example, the losses that we have in the propagation. So this is a big challenge when we are talking about the mining wireless designs. Another challenge, of course, that is that when the mining company is looking for a private network, as we saw before in the motivations, they are looking to increase productivity, right? So they are bringing the right now we can call mining 4.0 applications. So the idea is to increase productivity with increment in the safety, right? So it's very important to maintain or increase the safety in the mining operation. And for this reason, they are using a lot of different applications. And of course, when we talk about different applications, we need to understand and ensure the accuracy of the design, right? So we need to guarantee the accuracy of the project, and that we will reach the KPIs, and we will select the best technology for each environment, for each mining. So the big advantage to use a tool to perform the design in the mines is to create different scenarios and test different technologies. So today we have a lot of applications in different technologies, and we can have the same results with different technologies. So we can compare different technologies. We can compare costs. We can compare a lot of things in order to define the best technology, meet the KPIs, and of course, the design validation is a very important challenge, because all this mining will continue, right? So we'll continue the operation. So probably in the future, we will have new technologies. So we need to validate the design and prepare our solution for new technologies. And in IBWave, we have the solutions for mining private networks. We have the solutions to reach all these challenges and cover the entire process of a typical wireless design. When we talk about a typical wireless design or a typical wireless project, we will have different phases, right? But we can have in general the project plan phase, the survey phase, design, install, and operation maintenance phases. And we have a complete solution that can help the private network in all different phases. We have a mobile application called IBWave Mobile Survey. We have two different design tools, one for outdoor mines, that is IBWave Reach, another one for indoor or underground mines, that is IBWave Design. And we have a management platform called IBWave Unit that permits have the management of the project during the entire process, generating all necessary documentation and reports and dashboards in order to increase the collaboration and the integration between the different teams that will work in each phase, right? So if we look in general and very fast view, the idea of the IBWave solution is have a centralized end-to-end design for bad cost and quality control. So the idea is to have just one format, just one standard, the IBWave format, that will be a digital format since the beginning. So we will start with the first version of the project during the project plan phase. We can create this first phase in the mobile application or in the design tool. But the idea is to start with just one model, just one standard, create our template for this project, and then move forward to the different phases, just applying the changes and the new documentation and the new analysis that we will have in the next phases. So we can move forward and exchange the versions between mobile and project and design applications. And then we can do the pre-design, we can perform the complete design, the fine design, then we can provide the installation documentation and reports, and then we can validate the design, and then we can help with the operation and maintenance, especially using Unity, because the idea of Unity is to have the full control of the entire phase, the entire process. So in Unity, we have a synchronized site database, and we have an advanced data mining and reporting. We have unlimited workflow to follow up the project during the different phases. We have a powerful reporting. We have dashboards. So we have a central database of components and very powerful collaborating and file sharing platform. So this is the full solution. This is the entire IBWave solution. Of course, you don't need to have the entire solution, right? You can work with different tools, but the idea to have the entire solution is to save time and accelerate time to revenue as fast as possible, right? And prepare your design for the necessary upgrades or for the future technologies, right? Now I will show you a demo. So I prepared some demo in different mine environments just to show you the project tools. Of course, I don't have time to show the entire process, right, or the integration between the tools, but I will show you that with IBWave solution for mining, the RF engineers can model a surface or underground mining environment, and with indoor and outdoor network elements with different types of solutions and technologies, it's possible to do the complete design and reach the KPIs network requirements. So for the underground mine, remember that the tool is the IBWave Design Enterprise, and for surface mine, the tool is called IBWave Reach. Okay, so let's start with an underground mine sample. So I will show you the first one, and here we have our IBWave Design. In IBWave Design, here in the IBWave Design screen, you can see that is a Windows based tool, right? So the idea here is create the 3D modeling environment of the underground mining and perform all necessary analysis and prediction maps, right? In order to do that, in order to create the 3D modeling, I can work with different types of or formats of files. So I can work with an AutoCAD file of the mining plan, or PDF file, or even an image file. And the idea is to create the entire 3D modeling. So I will create the walls, I will create the surfaces, and then after create this 3D modeling, I will start to create my design. So this is a multi-technology tool, multi-banding, multi-frequency tool. So in this sample, I have two different systems. If you look here in the design plan, we have our unifilar diagram. And here I have two different systems. One in public safety system in P25 technology, and the another one in Wi-Fi. So here in the public safety system, I'm using radiating cables, and in some end of the cable, I have some Yagi antennas placed here. And of course, for the Wi-Fi, I'm using the access points. But here you can see that in IBWave Design, we can do the entire design, not only the RF source elements. I can do my complete design with the entire cable information, all elements. And here, in the P25 network, we can see that the tool automatically will calculate all link budgets for the system. So I will have the losses and gains calculations. So since I create my design, I can distribute the systems, the components here in the mine. So here I can see, for example, the different tunnels, and here in the tunnels I can see my radiating cable, right? So here, for example, I have my divider, and then I have this radiating cable that will provide the coverage in the entire tunnel up to the next divider. And here below I have the same for the antennas, right? Here I have the two YAG antennas. But here we are looking at 2D view, right? But here in IBWave, we have an option to see all the entire design in 3D. So if I launch the 3D view of this mine, I can see this complete design in 3D. And in 3D, I can validate for example, the tunnel modeling. I can validate the height of the components. I can validate the height, the position of the radiating cable, for example. And here in the tool, I just need to come here to the prediction panel and run the output maps. So for each technology, I can run different types of maps. Prediction maps. I can run coverage analysis, quality signal analysis, capacity analysis. And if I need to see some result, I just need to select here, for example, the sign strength, and I will see the coverage, and the propagation model will calculate the signal strength in each area of the tunnel, right? And if I select this option, signal probe, I can see the signal changing along the tunnel, right? So I can see the signal or the different levels of signal in the mouse location, right? And this output map I can see in the 3D as well. So if I come back here and launch the, for example, the prediction image, I will see the prediction here in the 3D as well. So the 3D is very helpful, very helpful during the design, and is another format to show the final design to the customer, right? So is another option to provide the documentation in the end of the design, because I can generate images, I can generate videos, a lot of types of information here. And here in the exploration area, for example, I have another system in Wi-Fi technology. So I can see here, for example, the same sinus range for the Wi-Fi system. I can define the prediction area, so I can define my area or specific area for the design, or the most important tunnels to cover, let's say. And I can perform, for example, another maps such as co-channel interferencing or maximum occurable data rate. We are talking about 2.4 gigahertz, right? But I can do the same for 5G. Here you can see that we already have 802.11 AX. So the tool is prepared for Wi-Fi 6, and I can see here the same output maps and generate the same analysis for 5G. And if we look for maximum occurable data rate, for example, in 5G, in Wi-Fi 6, we can see the maximum occurable data rate of 469 megabits per second. And if we compare with 802.11n, we'll see the difference, because here we have just 195 megabits per second, right? And of course, if I want to see the Wi-Fi in 3D, I just need to select the map here, come back to our 3D, and if I refresh here, I will see now the coverage or the output map there in my Wi-Fi system, right? And here we have a sample, or this mine sample is in the same level, right? All tunnels and all the exploration area, the entire mine is in the same level. And you can ask, okay, Milton, but how I can do this same 3D modeling in a different or multi-level mining or underground mining? No problem. We can do the entire 3D modeling in a multi-level mine. So I have another sample here just to show you this 3D. This is for a different levels. So it's a multi-level mine. I can do the entire 3D modeling. So if we go here, we can start in the entrance, right, of the mine, and then I can in IBWave we can model the ramps, the access ramps. We can model the different levels. And in this case, we have an LTE, a private LTE network with small cells. And for the small cell, for example, we can apply the necessary down tilt. So here in this arrow, we can see the down tilt that we can apply to provide a continuous coverage and connectivity here in the axis of the mine, right? And then if we go down, we'll see a second small cell here. And of course, if we want to see the entire mine, we can see here the different levels. So in this case, we can perform the complete design as well. So we can have the cabling, we can have the entire elements of the project. And if I want to see the output map, I just need to select here the prediction image, and then I will see the output map here in 3D. Oops, sorry, I unselect. See, now I can see the coverage in each level, in each tunnel, in each ramp, access ramps, I can see the entire 3D modeling. And here I can see, for example, the top view. And I will see in details the tunnels. So I have a lot of options here, a lot of tools here in the 3D to generate different documentation, different types of information, right? And of course, I can create the different reports. So in the end of the project, I can generate all necessary reports, since the link budget, automatic calculations, up to equipment list, that is the bill of material report, the cost detail reports, because I can define costs for each element. In the automatic, I will have the entire cost of the design, and of course output maps, compliance reports. So I have a lot of options in automatic reports to accelerate the design process, right? So this is the underground sample. And now let's move forward, and I want to show you another one in the outdoor mine environment. So now I will change the solution, right? I'm changing the tool, because for the surface mine, we need to use another tool, that is IBWave Reach. Why? Because when we talk about the outdoor environment, in the modeling, or the 3D modeling for the propagation RF propagation calculations, we in the outdoor environment, we work with another type of inputs, right? So in the indoor, remember that we can use an AutoCAD plan or PDF or image, but here in the outdoor, we need to work with geodata information, right? So we have a very typical sample here, is some outdoor or surface mining operation area, right? Typically here we will have a lot of exploration areas. So in these areas we have the exploration, right? But here we will have roads, we have access, we will have administrative areas, we will have a lot of important areas to provide the entire service in the entire mine environment, right? So here, in order to create the 3D modeling, we need to work with the geodata. And if we go here in the geodata information, in IBWave Reach, we can work with different types of geodata, okay? The most important in the mandatory geodata information is the height. The heights is exactly the terrain information. So we need to have a digital terrain database to reproduce here in the tool exactly the terrain elevation here in this area, right? But we can work with more information. We can increase the accuracy in our predictions, because if I want to take into account vegetation, for example, or some losses that we can have here in the environment, we can work with clusters, right? So we can import clusters information. And if we have cluster heights, we can work with cluster heights as well. And polygons would be, for example, if we have or if we have some of these buildings in a digital 3D format, we can import here as polygons information, and the prediction and the propagation model will take in account in the prediction in the output maps, right? Here we have just the geodata. We have just the terrain, sorry, but this is a very important thing, because as I said before, this environment is changing every day, is changing every week. Why? Because especially the exploration area, these areas here will change according to the operation of the mine, right? So this area is changing every week. So when we create the project here and import the digital terrain, I can buy a digital terrain database, for example, in some digital terrain database provider. But when we buy a digital terrain, this digital terrain represents some specific date, right? So depends of the final update that the company had in the information. We will have exactly a picture of that specific day, right? And in the mining, this is changing, right? So typically the mining companies has their own terrain database. So they have some agreements with terrain companies, terrain database companies, to update these changes every week or every day or every month, right? So we can use this information here in IBWave Reach. How we can import the information coming from the mining company database. In this case, I used the shapefile information. So we export the information from the mine database system, and the information come like this one, like a shapefile with lines, right? I'm just launch here. So we can see a lot of lines, and each line here is representing different elevations, right? So you can see that we had a lot of lines because here we have a good resolution. Here we are talking about 2 meters resolution, and with this shapefile information with the elevation of the terrain, we can run in the tool. We can run some tools, and we can create the digital terrain information with these lines. So we will create this digital terrain exactly to reproduce the real environment, right? So we can update this environment according to the new updates that we have in the database. So let me remove the lines. So now we can see that we have here exactly the same the 3D modeling of the terrain, right? So exactly according to the database, we will create our digital terrain. And then, of course, how we are talking about outdoor, I will just remove right now. And how we are talking about outdoor, in the outdoor networks, we work with towers, right? So normally we will have existing towers. So in each existing tower, we can create our sites. So for each site, we can create different sectors. And if we go here in tower 1, I can create the entire system configuration. How we are talking about LTE, I can have all LTE settings here for each sector. And for each sector, I will have a specific antenna with a specific pattern, right? But I can set, of course, the azimuth, the height of the antenna, necessary down tilts, for example. And after create the entire network, I just need to run the analysis here, and then I will see here the output map. So this is the area SRP prediction, for example, in the entire area. And if we pay attention here, exactly here in this operation zone here in the mine, we can see that here we have some poor signal values here. We have something around nag 105 to 125 dBms for RSRP. So here, depending of the application, if you are running an autonomous truck, for example, here we can start to have some connectivity problems in this area, right? So typically, to solve this problem in the exploration area, the mining company will not have or will not build a new tower here, right? Just for this area. So normally they work with mobile sites exactly here in the tool, that is a benefit of the tool, because here I can create a mobile site. I can place or find the best placement for the mobile site. And when we run the prediction again, taking account the mobile site, I will see the coverage with the mobile site. And then I can see that with the mobile site in this point or in this placement, I will solve that shadow problem, coverage shadow problem in that region, right? And of course, I can generate another maps. I can do the same that we can do in the IBOA design. So I can do coverage maps, quality signal maps, and we can do a lot of analysis here. But another important application in IBOA solution is the integration between the tools. So let's say that in this mine environment, for example, the mining company will need to build a new warehouse, for example, in some place here, and I have the warehouse plan, I have the warehouse design, but it's just a plan, right, for the next year. So if I have this greenfield situation, for example, for an existing building, I can using the integration between the tools, I can do this analysis and make sure that with these towers or with this private network system, I will cover the new building, for example, even the existing buildings. But in this case, let's say that I have a greenfield building. In order to do that, I just need to go there in our IBWave design, and here using the AutoCAD or the documentation that I have of this new warehouse, for example, I can create the 3D modeling like we did with the underground mine. And here, when we create our indoor design here in IBOA design, we will generate our EBW file, right? And then if we go there in the outdoor tool, I can make a link between the tools. So I can come here and I can point here in the campus option. I can point here, for example, where I have my EBW file, where I have this building design in IBOA design. And then here, how we have that building geolocated. If I select here, I will see where will be the building here. If I have the position and the azimuth of the building here in the area, and if I have the prediction, right, of the private network system, I can export this outdoor signal in order to see if the outdoor signal will attend this building, right? So here, looking the outdoor signal, I can see that here we have something around neg 95, or is higher than 100, neg 150, right? So looking this map, I can say that yes, we can provide the LTE coverage here inside the building. But remember that this is an outdoor analysis, and we don't have the entire detail of the building. We don't have the level of detail that we can have in IBWave design. So with the integration, I can export this prediction, I can export this outdoor prediction, and I can come back to our IBWave design. And here in IBWave design, I can work with the same IBWave reach signal. So I can come here in the prediction menu, and I can import the outdoor prediction. And when I import the outdoor prediction, I will see the prediction, the outdoor prediction here in IBOA design. So this outdoor prediction that we are looking here is exactly this one. It's exactly this one. In reach, we just have a different color, different range colors, right, in the legend. But this is exactly the same outdoor prediction. And the idea here is the idea here is to take advantage of the benefits in IBWave design, because in IBWave design, remember that if I launch the 3D view, I have the entire building in details. I have the detailed 3D modeling. I have all different walls. I have the detailed 3D modeling, the columns, the walls. I can model, for example, trucks. I can model everything that I have here in order to create, for example, the worst case. And then I will run a prediction here in the indoor tool that will be the interpolation sign strange. So when I run this output map here in the IBWave design, I will take the outdoor signal coming from different towers, and I will interpolate this signal inside the building using the 3D modeling that I have here. And if I launch this one, we can see the impact of the different materials. We can see the losses of the materials. We can see the losses of the columns, the outdoor, the surround wall, right? So if we go to the 3D, I can refresh here and activate the prediction, and we'll see that the outdoor signal is still the same, right? But the indoor signal, I will see the impact of the internal walls, the internal 3D modeling. And I can see that, in fact, here in the indoor design, I can see that I cannot attain the KPI. Let's say that my KPI is neg 95% dBMs in 90% of the area, for example. And here, when we run the output map, we can see the result here in the ledge that we are reaching just 41%. So in red is showing that we are not attaining our KPI. So if you are not attaining this KPI, I need to provide an indoor solution here. And if I provide an indoor solution, for example, with small cells, I can run another map with the indoor solution. And running this map with the indoor solution, with the indoor solution, I have 94.5% with the minimum of neg 95 dBMs. So I can see that now with the indoor solution, I can solve the problem of the outdoor signal, right? I can do the same here. If I want to see, for example, the impact of the indoor there in reach, I can do that. I don't have time to show everything, but when we are talking about IBWave solution, we can see that we can solve, or we can reach all challenges that we are looking during the presentation, right? So just to finish here and to do some conclusions of the demo, with IBWave solution, we have key benefits, right? You could see that we have a time saving or large environment modeling, greatly attending any type of mining, or we have solution for all different types of mines and different types of mining design environments. We can provide a greater quality design, right? We have one holistic design for multiband frequency and technologies. You could see that we can validate KPIs, we can apply changes and make analysis with coverage, quality, and capacity, and we can apply changes up to attain all necessary KPIs for different types of applications. And we have an enhanced design for future networks. So especially now that we are talking about 5G, about HetNet, about a lot of new technologies, since we have our project, or our first version, and we have the first 3D modeling and the first environment, or our first project, I can perform any type of analysis. I can create new scenarios with new technologies. So I can consider outdoor and indoor signals. I have this integration, and I can have and solve any concerns on costly file migration programs, for example. So I can validate, okay, in the future, if I want to implement a 5G, I have the environment, I just need to create the system and evaluate the cost. So a great benefit for the mining companies right now for telecommunication systems is to have investment plan for telecommunications as well. So for this reason is one of the top 5 priorities of the mining market today. This is basically what I would like to show you today. Now we have some time for question and answers.
Yeah,
Please,
great.
Kelly.
Yeah, sure. Thanks, Milton. We do have some questions to try to get through here. We only have about 5 minutes, but we'll make it through what we can. So the first question, Milton, is does IBWave have material loss, reflections, and diffraction values for a variety of mining materials?
Yeah, sure. When you are talking about the materials, for example, we have a powerful propagation model, right? Is a proprietary propagation model, and this propagation model takes into account all possible paths, including direct line of signal, reflections, diffractions, refractions, and in order to do that, we have here, for example, for each material, if we double select, for example, the wall here, we will see that we have some existing indoor mining walls materials or surface mining walls materials, and for each one, we will have the specific parameters for the entire calculations. Since the losses by different frequencies, right? Because we are talking about different frequencies. So for each one, we will apply the transmission loss and conductivity values. But here we have the electrical values. So here we have the values that we need to use for incident loss, incident reflection loss, the electric permeability values for the entire calculation, taking account reflections, diffractions, and refractions.
Great, thank you. For the modeling, are you converting the 2D PDF layout of the mine and converting to 3D? And how long does it take to change all the roof heights?
Yeah, in fact, it depends, right? I showed you 2 samples here, one with just one level, another one with multi levels. The best format is the AutoCAD file, right? Because in the AutoCAD file we have the layers, so we can work according to the different layers, especially if you have the layers separated by material, for example, because we can apply different materials per layer. We can use the PDF file. We can work with the PDF file, but we don't have support for the 3D PDF right now. But we can import the PDF file and create the walls using the 2D PDF, but we will create the 3D modeling use the PDF as well. And the most important is to understand the architecture of the mining, especially when we are talking about multi-level mining. It's important to understand before you start to model. It's very important to understand what are the different levels, the different heights, to find the best format or the best way to perform the 3D modeling.
Okay, great. Okay, another question here. Is it possible to predict rank indicator for MIMO 4x4 scenario?
Yeah, sure. For in both tools, when you are creating your system, right, you can define the system properties. So here, for example, we have the wireless services, and for each one, when you select the band, you will have access for all different technologies, and you can see that we are ready for millimetric waves as well and 5G, right? And for each one, when you select the band and define your technology, you can create the properties of each one, and we support up to 4x4 MIMO for LTE and 5G, and now it's possible to create SISO and MIMO system in different configurations. Yes.
Okay, I'm going to try to squeeze a couple more in here. Can IBWave realize the calculation of the leaky feeder antenna cable?
Yes, sure. In this case, we have a radiating cable, right? So we are calculating the propagation of the radiating cable. But if you are using a typical cable, for example, automatically IBWave will calculate the entire losses according to the cable length, for example. So all these information regarding the cable loss and the cable characteristics, you don't need to take care during the design. You just need to do it, and the tool will calculate everything automatic.
Okay, great. And that brings us to the top of the hour here. So unfortunately, we couldn't get to quite all of the questions, but we'll look to actually do a blog post that will answer some of these questions and get the answers out to everyone who attended. So a big thank you to everyone who registered and attended the webinar today. It was really great to have you here. We hope that it was of value to you and you walk away learning something you didn't know before. And a big thanks to you, Milton, for doing the presentation with us.
No, thank you. Thank you for everybody to share your time and attend this webinar. And I hope that was helpful for each one. And as Kelly mentioned, we didn't have time to answer all questions, but we can send you the answers by mail, no problem. Thank you, everybody, and take care.
Okay, thank you, everyone. Bye-bye.